Okay, welcome. Thanks for this, for the RISC-V Summit to host us in the demo theater here. So my name is Kamal Desai. I'm from Synopsys. I'm a product manager in our virtual prototyping group. And today I'll just spend a few minutes talking about how you can accelerate software development and do some validation earlier in your design. Okay. So this presentation done by me and one of my senior solutions engineers, Sam Tennant. So before I get into the actual virtual prototyping itself, just want to let you know that Synopsys itself has actually been involved with RISC-V for a few years now, right? So some of you may be familiar with the verification tools, the emulation tools, the hardware-assisted verification with HAPS and so on. So I've got some examples here on how Synopsys itself has been involved in validating and verifying some of these RISC-V designs, especially for software development, early software development. So it's not just about virtual prototyping, but it's also for software development. So we have a broad array of tools that let you do early software development. But what I want to focus on today is really the virtual prototyping piece. There's other elements of this where you can do hybrid, where you can use a virtual prototype with an emulator. You can use a virtual prototype with a FPGA prototyping system. Okay, but given the time, I'm just going to focus on the virtual prototyping. So the hardware-assisted verification platforms, this is just the complete portfolio of solutions that let you do early software development, okay? And so like I mentioned, I'm just gonna focus on the software bring-up piece here with Virtualizer and how does that actually work with some of the modeling capabilities that we've created. Just some customer success stories. I also want to plug in the what we have is cloud offering, so you can actually run your emulated system in the cloud, right? So we have this tool here called ZeBu Cloud. And so here's an example here of how ZeBu Cloud was actually used to develop some of these RISC-V SoCs. So you don't actually have access to an emulator, you can do this via the cloud. And then the final example here is using our HAPS 100 system. So again, here we have 4 RISC-V cores, basically it's the Rocket cores, and again here we're using RTL debug with one of our other debug tools called Verdi to actually do the software development. Okay, so those are some of the examples of other tools that Synopsys has to do early software development. What I want to focus on today is the use of virtual prototypes. So basically, Synopsys has this tool called Virtualizer, and it's targeted mainly for early software development, early software testing, and you really want to think about using this tool in the absence of any hardware, in the absence of any access to RTL, which the other tools require. Right. So in this case, this tool is really all model-based, and so basically what we do is we create models of your different systems. We import those models into this Virtualizer tool, and we create what's called a VDK. A VDK is a Virtualizer Development Kit. It's basically a binary that simulates an end hardware system, right? But it's all pure software. So you just have a model of a system that emulates your software. So again, here when I say it supports all Virtualizer VDK functionality, this basically means it gives you all the software development capabilities, the software debug capabilities. And so in the last year or so, we've actually augmented the model capabilities with many RISC-V systems. So just this week, you heard about the Synopsys ARC-V release. So we have models for those coming up in Virtualizer support. Over the years, we've added support for SiFive, Andes, and OpenRISC-V. So what we do is when we engage with customers, they come to us and say, do you have a model for so-and-so? We engage and we just kind of augment our model support with these different libraries. Okay? And so those of you who are actually familiar with virtual prototyping, Virtualizer in particular, the infrastructure is exactly the same, right? So what you would do with an ARM system, you can do with a RISC-V system. So we don't change anything as far as the IDE goes. It's the exact same implementation. So the connection to the debug server, the connection to all the analysis tools, the connection to your post-analysis tools, those are exactly the same. And so those of you familiar with your typical GDB, Eclipse type environment, it's all based on that as well. Okay, and then what we've actually introduced in the last few months now are these starting points, right? So we call them RISC-V starting point VDKs. So as a developer, you're going to have all these different models. It might take you a few hours, a few weeks, a few days, depending on your expertise, to actually get up and running. So what we've done is we've created what we call these starting point VDKs. And we have a whole bunch of them. So we've got the Synopsys ARC-V starting point, we've got the Sci-5 starting point, and we've got the Andy starting point now. Right? And the point of having these starting point VDKs is that it just gets you up and running in a day, right? It's a pre-configured system that lets you just basically run, and then once you have that system up and running, you can go in and modify it to suit your particular needs. You want to change the cluster type, you want to change the core types, you want to change the actual operating system that's running on there. So you can do all that based on this RISC-V starting point, right? So we call it start your software development in a day. You just install this. It takes you about 30 minutes to install it. And you can just basically run simulate and away you go, right? And then the rest of it is up to you on how you want to customize that starting point now to for your particular application. So does it make sense to everybody? Right, so it's easy, RISC-V, yes, we can have models, we can integrate them, but the point here that I wanted to talk about today is really starting point reference VDKs. And so with that, being a demo theater, I have a demo video of one of these starting point VDKs. And so when you start up your system, you basically get, we call it an extensible or configurable VDK. And it's just a block diagram. It's got all the components at the top there. You don't have to do anything, you just install it, and this is exactly what you see. The key that I want to show you here is, you know, you've got all your memory components, your peripherals, you got a UART there. And in this particular case, the starting point did not have an Ethernet subsystem, so we were actually able to add an Ethernet subsystem as a peripheral to your starting point. And then you can actually go in and look at the details of your CPU subsystem. So in this case, for RISC-V, you've got the PLIC, the CLINT, your interrupt controllers. You can actually go in and examine your core block in more detail. So in this particular example, we took the Sci-5 starting points. In this case, it's the Sci-5 X280. Okay, you can go look at the details of each of those clusters. And then once you have the starting point, you can actually go in and modify it to suit your particular needs, right? So there's basically a pull-down menu that tells you what available cores, what models of those cores are available. So based on that configuration, you can go in and specify a particular model type. Whoops. Sorry, I clicked that to the end. Okay, so this is what I mentioned. You can basically go in and reconfigure your system for different RISC-V cores, and this is probably the most useful part of having these starting points, right? You got your list of models that you have. If you don't want the X280, you want to switch to an Andes core or RX45, you want to switch to an open hardware core, you can just go ahead and make those changes in there. You can change the internal memory, you can change the peripheral support. And then again, so all these starting points, they actually come booting Linux, right? So out of the box, there's actually a challenge for a lot of these models. As recently as a year ago, just to get Linux booting on any of these systems was a challenge. Okay, so these starting points out of the box, they boot Linux. And you'll see the OpenSPI boot, and then the actual Linux boot. So this is all out of the box. You don't have to do anything to actually configure your system. You just click run, go, and then all you do as the developer is you extend it and customize the starting point, right? So it really gives you a heads up in accelerating your model development there, okay? And then Once you get to this stage, those of you familiar with the whole debug analysis piece, now you can just attach your standard GDB debugger, and all the RISC-V specifics are supported there on the GDB side as well. So in the interest of time, I'm just going to cut it short here. But so you can look at your register values and anything that you typically do as a debugger, set breakpoints, stop the code, run the code, and so on. So any questions on that? Yes, you can. So the question was, can you add other logic components on the side? Yes. So when you say it's extensible and customizable, that's really what it's all about. So, okay, thanks for your time.